Hello. This is a video about SeaBrick, and in particular, the geometric features of SeaBrick, rather than the composition. This particular video will focus on the physical shape of the SeaBrick and the engineering capabilities and architectural opportunities that it will create. So here we have a SeaBrick. First thing to note is that this is not a full-scale SeaBrick. It's a 10% scale SeaBrick, so it's 5 centimeters by 5 centimeters by 2 centimeters. And a full-scale SeaBrick would be 50 by 50 by 20. And that size was chosen so that it would be about 25 kilograms. So a normal human being can lift that amount. And we are always going to be engineering this with the view to having the lowest tech solution possible available at all stages. So first thing to notice is the dots on the top, similar to the kind of dots you might see on a Lego brick, except that they don't click, and also that they're arranged in a slightly different pattern. These are not on a square grid, they're on a hexagonal grid, for reasons that will become clear. And so they have these dots on the top, these bumps, and they're mirrored with cavities on the bottom. So when you layer bricks on top of each other, they lock into place. Perhaps the most obvious feature of the brick are the tongues and grooves. So it's kind of a jigsaw lock. And notice that the left and right are not quite the same as the top and bottom. On the left and right here, the tongue is on the top, whereas on the top and bottom, the tongue is on the bottom. So it alternates. These two are on the top, and these two on the bottom. That's also got a reason. The last thing possibly to observe is the little groove here. Right, that, and there as well. And actually in all four corners have these grooves. And that will also become more clear as we look at the bricks assembled together. So this is a single brick, obviously. And then we can take another brick, a second brick, and align them, and lock them together, just like that. It's pretty simple. They're also quite stable once you lock them together. And we also take another brick, a red one, and a black one. So it's kind of a nice interlocking system. They're quite connected, and also quite stable. So the point here, the stability of the locking, is that you don't want these things floating around in the ocean by themselves. Once they get locked in, you want them to stay locked in. That's a big purpose of this particular lock design. And also, when they're in a stable location, a stable position, there'll be a gap in between of about 2%. So that will also become clear. So those are square blocks locked together. And also you can see here, by the way, now that they're locking together, that groove formed a circle. And it's got a circular groove in there. So those are the square bricks. And we also have triangular bricks. So the reason why the dots were in a hexagonal pattern is because the overall geometry of the brick system is on a hexagonal pattern, because we want to integrate both square bricks and triangular bricks. So we can take one of these triangular bricks, which has all the same features, except that on the triangular bricks, in this particular one, all the tongues are on the top. But otherwise, it's the same. And it will lock in. Boom. Like that. And they're equilateral triangles, so 60-degree angles. So they'll go around, and 3 of them will be 180 degrees. So you can, and that locks onto the square system. That opens up a whole bunch of different opportunities, and You see also that creates the circle there as well. For example, you can have shapes like this. You can also have shapes like this, where all the shapes are triangles. And you see now that hexagon pattern is arising out of that. Hexagons and triangles are very related. A hexagon is basically 6 equilateral triangles together. So you can create these hexagonal shapes. And you can do this by putting triangles together, or we can just also use a straight old hexagonal piece. And so these bricks come in a variety of different shapes. There's the square ones, the triangular ones, hexagonal ones, and many ones in between. So for example, this is a square brick but with a straight edge, and there's, just like you might have with a normal Lego set, there's a variety of different shapes based on the underlying pattern of these locks and bumps. So